So today we are going to do the case study. We will be taking two data sets. One is the Titanic data set, and the second data set we will be taking is that of the COVID EDA, COVID data set. Okay, so first of all, I'll be taking all the important models. SNS. Okay. So these four libraries we will take, and then we will be importing the Titanic data set. So this Titanic data set is already available into the C1 library. And for that, what we will be doing, we'll be writing here Titanic is equal to SNS dot load underscore data set. You remember we have taken this the tip data set, right? So similar to that, this Titanic data set is also available. We don't have to download it, so you can just check this one. So this is the Titanic data set we have. In that we have the survived column, passenger class, sex, age, sibling or spouse were there or not, parent child relation, then fare, embarked from which location, class, again third class, first class or second class ticket, with whom they have boarded, so man or woman, adult male were there or not, yes, so true, I know, then false, deck, so where it was decked, okay, embark town, Southampton for this passenger, and alive or not, and then alarm. Okay, so survival has only two values, 0 and 1. Alive also has only two values, yes or no. Alone means whether the person was alone or with some child, or with some spouse or siblings. So those all details you'll be getting. Okay, so we will be plotting this data. We have total around 891 rows and 15 columns. We are going to plot this data. So before plotting this, just a second. Okay, so I'll be showing you a few plots on this Titanic data set, and then few of the plots I'll be leaving it to you guys. You can go ahead and practice them. So what I will be doing from my end, I'll be explaining few of the like the plots which we have used and which we have learned till now, and the plot which we have not learned, few of them like bar plot and pie plot, those plots we'll be learning here. And let's see this one by one. So first of all, we have this Titanic data set. If we want to get the the info on this data set, so we have titanic.info, and that will be giving us the information about the every column. So survived column have 891 rows, and age column has 714 rows, deck column has 203 rows. Rest all values are null or not defined. Okay, non-null we have the values. Then int 64, the data type, basically it is showing what is the data type. Okay, so this info gives you the details about the every column into the data type. Fine.
Some things he took as object because they're all simple columns, right? Column values. So
Object are these values. So if you have some string value and all, so that are coming as object.
string is coming as object. Okay.
Okay. Now we are going to do the category. Sorry, this what is it? Okay. So basically, we are going to check which all values are null. Okay. We want to know that which all values are null, and then we will be plotting that in the heat map graph to check the columns different none value or null value. Okay. So first of all, I'll be writing Titanic dot is null. Okay, that is going to give you a row. So this gives you the a matrix, boolean matrix, based on the null value. So if a value is null, then it will be replaced with true, and if the value is not null, then the value will be replaced with false. Okay, so in the survived column, you don't have any null value. Okay, in P class you don't have any null value. Yes, in the deck you had few null values. Okay, in the age also you had some null values. Okay, you will find it true somewhere. Okay, fine. So basically it is going to give you a matrix with values where the values, if the value is null, any value is null, then it will replace it with true, and not null, then it will be replacing it with false. Now if you want the sum of the in the different column, what is the total number of null values? So you can get it here. Like you can see in the age you have around 177 values are null. In death we have around 688. In embarked you have 2, and in the embarked town you have 2. Okay, fine. So these values are not available. Now, next we want to plot this null values in the heat map graph. So we will be using heat map. We are passing the Titanic dot is null, whichever value is null, that matrix we are passing. Then C map color map, we are using this color, and this is the color code. C bar color bar we want equal to true, we have set. Okay, so this is the color bar, and you will see that it is plotting that which all values are null, that is coming into the yellow color. So deck was having more null values, around 688 null values are there. It is shown like this. Okay, now we are going to find the plot the heat map for all the correlated data set. So correlation matrix basically we are going to find. So the function we have seen for finding the correlation is the core function. Okay, so this is the core function, and this gives you the correlation matrix. Now if you'll be plotting it using the heat map, so this will be giving you this plot. Okay, fine. Okay, now next we are going to do the univariate analysis. So we have already
Abhishek,
done.
sorry to interrupt. Can you just go little bit up?
Sorry, which one?
Okay. You have find out correlation matrix, then you are plotting that one. Okay.
Yes.
I want. Can you go to input 6 also, please? Yeah, one second. Heat map Titanic is null. Yeah. Okay. Thanks, Abhishek.
Done.
Yes, Abhishek. Done. Thanks.
Abhishek, can you explain what those two parameters C map and C bar is in input 6?
Abhishek, I guess you are on mute.
You can set the different color map. Okay, so I have set this one, and it is showing this color. So the different values you have for C map, if you want to find the value, you can figure it out. Okay, C map in heat map, you'll get the different C map values, what all values you can keep in the heat map. CMap controller. Yes. Okay, so this value, next, only 4 values we have, no problem. Control color in seaborne heat maps. Okay, so these all are the different schema values, BU, PU, or greens. You can keep anything, and it will be showing you the color into this. So it is coming into this color. Okay, so you can set the different color here, which color you want. That color you can set into the schema. And C bar is this color bar which you can see on the right hand side. If you set it as false, then it will be not showing this color bar. Okay.
What does this bar tells us?
Which bar?
This C bar, which you
Bar
had.
is just the color bar, okay, and it tells us that which if the value is not present, so it is 1. If the value is present, then 0. Okay, so null values are present, like wherever null values are present, that will be replaced with the dark green color, and wherever null value is not there, that will be replaced with this light green color. Okay.
Okay.
It is legend for continuous values.
Sorry.
It is basically legend for continuous values, right?
Yes, yes. So next we have the univariate analysis. We can do this univariate analysis with the count plot. Okay. So first of all, we are going to set the canvas and axis, and we'll be doing the count plot on this. Fine. So we are setting the canvas and axis. In this, we are using sns.countplot function. Okay. In the seaborne, we have the count plot function. What we are plotting, we are getting the count plot of survived column. So how many people survived, how many people did not survive. Okay. And so we have passed the survived column. Data, we are passing the Titanic data set. And in what? So if you see here, we have 3 cross 3, means 3 rows and 3 columns. So first matrix or the first element is accessed by 0, 0. The next one is by 0, 1, 0, 2. Then 1, 0, 1, 1, 1, 2. Then 2, 0, 2, 1, and 2, 2. Out of this 2, we have distribution plot, dist plot function you have learned, right? We are using dist plot to plot them. And rest all we are using the count plot. So if I'll be executing it, 920. Okay, I'll be coming to this. So you can see this is the survived column. This is the passenger class column. This is the sex column. So survived column, how many people did not survive? More than 500 people did not survive. From this data set, we can visualize. And how many people did survive? Around 300 people, little more than 300 people survived. Okay. Clear? Okay. Next, we have passenger class. So in the passenger class, we have first class passenger, second class passenger, and third class passenger. So around little more than 200 passengers were there who traveled into the first class ticket, and second class we have little less than 200, and most of the passengers were into the third class. Okay, and so on. So you can get the sex also on how many male and female were there. What was the partition, means how many people were there who were boarded alone. So more than around 700, little less than 700 people were there. In a group of 2, around 100. In a group of 3, little less than 100, or little extra than 75 or 80, you can say. And with this increasing number, less number of people were there. Okay. This tells you alone, sibling, spouse relation, and this shows you the fair distribution. Okay, so this shows 0. So most of the people who boarded, this shows again the distribution. If you will be plotting this, so you'll be getting around 35% in the KD plot. 35% people were there who boarded, with no, by giving no fare. Okay, few people who gave less amount, between 1 to 10 rupees, and very few people were there who gave more than 100 rupees, okay, or $100, whatever it is. Or pound. These two plots I'm not getting. Last one, age and embarked. Okay, this is the one, 2-1 and 2-2. Okay, why? Because we have in the age column, we have few null values. Okay, so that null values has to be replaced. How we can replace the null values? So to replace the null values, we have Titanic dot age dot 11. Okay, so this is replaced by 0. Now let's execute this. Now we have the plot of the age. Okay, right. So we have replaced the null values with 0, and then we are plotting this graph. Okay, because this is the numerical data, and numerical data cannot have the null values in the list plot. So we have replaced the null values with the 0. Okay, fine.
Abhishek, can you just go up? The 7th one, fair, was also having like a NAND, right?
Okay, yeah, fair was not having NAND.
Like there was 3 columns having some NANDs, right?
Let's see that. Fair was not having null value.
Oh, embarked is having, right? Okay.
Okay. So this is the
Abhishek,
can you-
it went little fast. Can you explain the input section, please?
which one?
This one, yeah, input section, yeah.
Okay, so we are doing the count plot. In the count plot, on y-axis we get the count, on x-axis we need to plot some column. So on x-axis we are taking survival column or p class or sex, and accordingly the count will be given. Okay, you don't have to take the second argument here. Data we are passing as the Titanic, and in which graph we are plotting, that graph value you have to give here. So we know that this is 0 row, this is 1 row, and this is 2 row. Column, this is 0 column, 1 column, and 2 column, right? So this will become 0, 0, this will become 0, 1, this will become 0, 2. That's what we are passing here. 0, 0 for the first graph, 0, 1 for the second graph, 0, 2 for the third graph. And then this will be 1, 0.
Abhishek, I mean, I'm not able to understand this axis 0, 0, 0, 1.
Okay.
It is coming from the data set, like that. 0, 1, 1.
Not data set. You remember subplot? I have discussed this subplot in the last class. If you see here, what I have created, it is this plot or this graph is like a matrix. Okay, and you can number it along according to the rows and index column, row and column index. So the first, like how many rows and how many columns we have set here? 3 rows and 3 columns. Correct?
Yeah.
So 3 rows and 3 columns. So column and rows and column starts from 0 index, right? So we have 3 rows. This is first row, this is second row, and this is third row. Okay. And row indexing starts from 0. So this will be 0 index, this will be 1 index, and this will be 2 index, right?
Okay.
Row wise, column wise, this will be 0 column, this will be 1 column, and this will be 2 column, correct?
Okay.
And this is the intersection of 0 row and 0 column. So this will be set as 0, 0. Correct?
Yes. Yeah.
Okay.
Okay. We are taking a subplot of 3 by 3. So from that we need to take the axis.
Yes.
Okay. Got it.
Any other question?
Abhishek, it's just a query. So if somehow like I provided the survived and P class on the same axis, how it will be? coming? It will be like an
It will be
overlapping.
giving you the error, I think. Let's see that. Comma this, execute this, it is error. Okay. Cannot pass values for both x and y. Okay.
No, not like this. So in below, if we are providing the access, there also if you are providing a same. So first it is already added, right?
Hmm.
So in that line 4,
Hmm.
in the axis parameter, you can provide it as 0, 0. So
Oh, okay. Here you are saying 0, 0.
uh-huh.
Okay. Let's see that. So it is giving you the P class, the last
Okay.
value. It is not giving you the survived one.
Okay, it is replacing.
Yes.
Okay.
एंड ये तुमको समझ में आया ना कि काउंट प्लॉट में
Okay. Okay. So next we have the survived column analysis. So in this survived column analysis, first of all, we are going to get the total value count. So Titanic of the survived column. Okay, this is the survived column. SURVIS is small. This is the survived column. Now I want the value count. So I'll be using value underscore counts. Okay. So we have the non-survived 549 and survived 342. Okay. People who did not survive, that is 549, and people who did survive, that is 342. This is the exact count. Now, if you want the individual count plot of this, so we can use sns.count plot to plot survived and data is equal to Titanic. Okay. Plot title we have given using plt.title and the plot name Titanic survival plot, and this is what the plot we are getting. Okay. Now, if we want the histogram plot for this, then we will be plotting for the survived column. Plot.hist is the function which gives the histogram plot. This also gives me the same information. So 0 is non-survived, 1 is survived. On 1, we have around more than 300 people who survived, and along 0, you have more than 500 people who did not survive. Okay. Next, we have the pie plot. So if you want to do the pie plot of the survival column, then you can do this plot.pie, and pie function gives you the survival plot of the graph. And also we have one auto PCT attribute for the pie plot where you can set the percentage. Okay, how many people, what is the percentage of the people who did survive and not survived. Okay, fine.
Abhishek, just query. So in subplots also we can able to give the titles for each of the graph or
Yeah. Yes.
yeah.
Yes. Yes.
Okay.
Fine. So this is the pie plot we are getting, and next let's do this on passenger class. So for the passenger class, we are first going to get the value count. And this is the Titanic of P class dot value underscore count. Execute this. We are going to get the first passenger class around 216, second passenger class 184, and third passenger class 491. Okay. Now, if we want again the total count based on the group data. For example, we are going to group this data based on the passenger class and the survived column. So once you will be doing that, once you'll be grouping the data, so you'll be getting this group by object, and then what we want the survived column and their count. So I'll be using this survived dot count, and this will be giving me the data based on the passenger class, segregated on the passenger class and the survived column. So in first passenger class, how many people did not survive and how many people did survive. In the second passenger class, how many people did not survive and how many people did survive. Similarly, in the second class, how many people did not survive and how many people survived. Okay, so we have grouped this data based on 2 column values. Okay, fine. Now, if we will do the count plot of the passenger class, so we will be getting it. We have already seen this count plot of the passenger class. Now, what I want based on the survival column. So I can set a hue attribute here, adding another dimension. I'll be setting hue is equal to survived column. Okay. Now setting the survived column, it will be just giving me the data passenger class and survived column wise. So in the first passenger class, how many people did survive and how many people did not survive? This is the different data. Okay. In the second class, how many people did not survive? How many people survived? In the third class, how many people did not survive and how many people survived? Okay. Fine. Using hue attribute, we have done that.
Can you go to that group by once?
This hue and group by are similar. Are they both?
Group by is here. I have grouped the data, like this data frame I have grouped. Okay, and hue I have used in the plotting.
Okay, okay. But it is a plotting representation and that is a data data.
Yes, yes.
Oh. Sorry, I hijacked somebody's question. Sorry. Please go ahead.
Yes, please go ahead. Okay. Next, we are going to get the bar plot for this passenger class, and that will be giving me the percentage. Okay. So sns.cat plot we have. In this cat plot function, we can pass kind is equal to bar plot, or we can pass the box plot or the valid plot, and we will be getting the data. So we are plotting passenger class along x-axis and survived column along y-axis, and this will be giving me the percentage of the survived, okay, people. So in the first class, the survival rate was around 70%. In the second class, it was around 58 or 59%. And in the third class, it was around 30%. This black color bar is called the error bar. This represents the error in the data. Okay. So if based on the data, it is coming around 62%. But if the error is there plus minus, it is taking this data. Okay. So if it is plus, so it may go up to 70%, and if it is minus, then it may go up to around 55%. Okay, similarly here also. Fine. Next, we can have the line plot also. Kind is equal to point plot, we say. So kind is equal to point you can specify, and then you will be getting the point plot. This also shows you the percentage of the survival. Okay, in the first class, what is the survival percentage, in the second class and in the third class respectively. Next, we can set the valid plot also, sns.cat plot of valid plot, and this says you again the survival rate and non-survival rate. So 0, you can see 0. This says the survival rate is lower than the survival rate is higher than the non-survival rate into the first class. In the second class, the survival rate was around similar. Okay, survival and non-survival, and in the third class, non-survival rate was higher compared to the survival. Okay. Fine.
Abhishek, one quick question. So can you go back to the earlier line, 36, I guess, 36, 35 and 36, how this error ratio is calculated? I mean, you are saying some error, right? It might go back to 70% or might be reduced to 55%. How this error is calculated?
That is already, like, that will always be calculated into the bar plot and the point plot. Okay, that data is taken. So any data you take, in that data, this will be taken automatically. So like, it considers some plus minus values. So this gives you like what is the percentage that probably will be discussed in your stats classes. Okay, when these plots will be discussed there. Okay, so
Okay.
every
it's like
even if we have 100% of the data, it happens.
yes, even if you will be having 100% of data, this error bar will be shown.
Okay, okay.
Every time.
So it's like a default percentage.
Yes, yes.
And Abhishek, is there any way we can hide this error, like to like not show up or something? Because in bar charts, generally, if we are going to present it to like a client or something, I mean, the error bars might not be that relevant to
actually,
like, you know.
it is better to show. It is better to show the error.
Okay.
Okay. So see, the maximum percentage you can show that it is the survival rate is 70%.
Mm-hmm.
Okay. So it is
Okay.
better to show the error bar.
Okay.
Okay. Next, we have the ED on the sex plot. So we can let me do one thing. So we are going to first check the count, value count. Okay. So that we will be getting, so how many male and how many female were there. And then again, we are going to group this data based on two columns, sex and survived column. And then we are going to get the survived data. Okay. So how many people in the female survived, how many did not survive, how many male survived, how many male did not survive. Okay. Now, so we have seen the count plot. You can do the count plot. You can add the hue attribute to this, okay, in the sex column. So for example, if I will be not writing this, so I'll be getting only the male versus female, but once I'll be adding this, so I'll be getting now the survived column also based on the, so hue is equal to survived. Okay, so with respect to male and female, you'll be getting the survival and non-survival rate. Okay, fine. Okay, next into the bar plot, we can set the hue attribute again. So we have seen the bar plot earlier, but we are now setting the hue attribute. Setting the hue attribute on the passenger class. So in the different passenger class, it will be showing me the survival rate based on the different sex. Okay, so we have the male and female data and the survival rate into the different classes. So this is the like if you'll see the survival rate into the first class, whether it was male or female, it was higher. Okay, second class female, it was higher, and third class it was lower. Okay, in both male and female. Fine. Now you can add the column attribute. Okay, if you'll be adding the call attribute, then for every passenger class it will be showing you the different bar plot. Clear? For the first class, for the second class, and for the third class. Clear? Fine, everyone. Any question? Okay, you can add this hue attribute to the, you can add this hue attribute to the point plot also. And I'm adding hue is equal to 6. I'm plotting along the x-axis, I'm plotting p class, y-axis survived column, and I'm adding 6 column to the hue attribute. So if you will be running this, you will get this plot based on the sex, male and female, you are getting 2 plots. And for the different passenger class, you are getting the survival rate. So if you see in the first class, female percentage of survival was around 100%. In the second class, the female percentage was around 90%. And in the third class, it was around 60%. Okay. Fine. Clear, everyone?
Yes.
Yes, Abhishek.
Okay, so now we are going to do the age analysis. Before the age analysis, we have done this one. Let's do the valent plot of the sex versus survived column. Okay, so now we are seeing the survival rate into the male was less, okay, and into the female was more. Okay, so we have plot sex plot versus survived plot, and we have got the valent plot for this. Okay, we are passing the Titanic data. Next, we can add the hue attribute for the every passenger, and adding the hue attribute for every passenger class, this survive sex versus survival plot will be shown into the terms of valent plot. Okay, fine. So you can add call attribute, hue attribute. So those all things you can check. I'll be sharing you the sheet where I have done this. So EDA on age analysis. Let's do that. Now for the age, so we are going to do the histogram plot. And for the histogram plot, we are having the bins attribute. So let's do this. First of all, we are passing Titanic of age column dot hist bins. We are passing 30. Density is equal to true, color is equal to orange, and figure size is equal to 12,6. I have taken. Now, if you see this, so this is the histogram plot of the age column. Okay, this shows the distribution that most of the people were young who boarded, so between 20 and 30. Okay, fine. Similarly, you can get the distribution plot also, dist plot of the age column, and that will also show you the same trend. So nan to integer, we have to set dot fill in a 0. Okay, fine. Okay, now next, let's say if I want the age analysis using box plot. Okay, so sorry, using some categorical plot. So let's do that. What we are going to do is we are having along x-axis we have sex and along y-axis we have age. So for male and female, we will be plotting the age data. So if I'll be plotting this, we are going to get the, this is called the swarm plot or strip plot. This is strip plot. Okay. So in this strip plot, if you see, most of the male who boarded were in the range 20 to 40, and female also were in the range 20 to 40. Okay, fine. And then we can get the box plot for the same. So if you want to get the box plot, so using cat plot only, you can set kind is equal to box, and then if you'll be executing it, you'll be getting the box plot. This also shows you the same data that into the male, most of the people were into 20 and 40 years, and mean was around 30. Same for the female. There were few outliers into the male who were more than 70 years old. Okay, and then you can add the hue attribute to this if you want. So in the hue attribute, I can set the P class. So for the different passenger class, it will be showing you the sex versus age box plot. So in the male first class, the people were 30 to 50. Okay, those who are having more money, and then though most of the young people boarded into the third class. Okay, whether third class passengers. So that was whether male or female, they were very quite young, 20 to 30 or 35 years of age. Okay, fine.
Abhishek, for the hue parameter, can we have two columns also?
No, only one.
No, because
You can
I was
have
just
two different plots for that. Okay.
okay. I was just thinking like okay, the male and age P class, and something else also like a survive rate also. I just need to check over here. So I was just thinking.
No, only one value you can pass into the.
Okay.
Okay. Next, let's do the swarm plot analysis on the age of the passengers. So for the swarm plot, we will be using kind equal to swarm into the categorical plot, and then it will be showing for the different passenger class the people who boarded. So in this case, you can see that into the third class, most of the people were young, between 20 to 30 or 35 years of age were there. Okay, fine. If you want, you can set the hue attribute is equal to 6, and that will be giving you the different male and female into the different classes. Okay, so male were blue and female were orange. So in the third class, most of the people who voted were male. Okay, fine. So this is it. These all are the different plots you can do. I have this practice set which I have completed. So there are different other plots also which you can do here. Okay, so same thing which we have learned, dist plot and histogram plot, and then the LM plot and all. So you can go ahead and practice them. I'm going to share this link with you guys, and you can go ahead and practice it. Okay. So these things now will be repeating. Same thing I'll be using box plot, or this everything will be showing in all the columns. Okay.
When I was running this swarm plot.
Yes.
Abhishek, I have one quick question regarding data preparation you did for age. Okay, so you have replaced all the null values or empty values with 0, right?
Yes.
So I mean, it's going to affect the ultimate the
Yes.
analysis that we are going to have, right? So how much error is allowable, and what are the other approaches of doing that without tampering the data?
Other approaches is you can drop those values which are null values. Okay, and how much error or how much missing values are allowable, so that you may probably be checking with the stats classes. So there is another EDA you are going to do into the statistics. There probably will be starting with the data preparation and the data cleaning part. Okay, so there probably the trainer will tell you into that EDA. Fine.
Okay. Okay.
As of now, we are going to replace. See, here we are not doing the EDA. Here just we are learning the features of the different plots and the different functions which we have learned till now. So you can replace it as of now. But when you will be going to the stats, and once you'll be completing your ML, at that time you cannot do that. So a few things will be cleared on in the project also, that what you can do with those data which are null values. So whether you can replace it with some default value, or you have to drop them. Generally, we drop them. We drop those values. Okay.
So you mean in real life scenarios, either we drop them or we take some other, like we can take means and replace something like that, right?
Yes. Yes.
Okay.
Fine. Now, next we are going to take the COVID data set. So for the COVID data set, I have already prepared the data set. This is available here into this folder. This is the 4 CSV files we have. I'll be showing you after importing it. Okay, so first let's import this COVID data set. Now, to do this data analysis, I will be using few modules which we have not discussed, Plotly and Folium. Okay, no need to discuss them separately. I'll be just using them. So whatever you have learned in Matplotlib and Seaborn, from there only the concepts will be used. If you have completed those Matplotlib and Seaborn packages, we have practiced them from the last class discussion, and then this will be easier for you to understand. So first of all, we are going to import all the libraries which we have discussed. So these all are the default library, and then we are going to import Seaborn. Okay. Next, we are going to import Folium. Folium is for the geographical plotting we are going to use. Okay, and Plotly is for the advanced plots we are going to use. Apart from that, we are going to import math, random, and the date time module as well. Okay. Next, we have the 4 sub module into the Plotly: Plotly.express, Plotly.graph object, Plotly.figure factory, and Plotly.subplots. From this, we are importing make_subplots. Okay. So we will be using for plotting the different graphs using Plotly. We will not be using Seaborn now. Most of the cases will be using Plotly. Why we are using Plotly? Because Plotly gives you the very advanced control on your plots and some UI based control also on your plots. We are going to look at them in some time. Okay. Next, we are going to use the color palettes also. So for the confirmed, death, recovered, and active, we are going to use this color. These color codes, you can get it from the internet. You can find the color code here. You can write here color code. Okay. And this is the HTML color code. So whatever color you want to use, you can use it from here. Okay. You can copy this color code and you can write it here. So I've used different color here. Okay. So this is for confirm. I think it is red. For death. For death, it is red. Confirm, it is orange. Recovered, it is green, and active, it is yellow. Something like that. Okay. So I've used the different colors. Okay. So next, we want this Plotly to work into the offline mode as well. So I'll be setting this py.offline and connected is equal to true. So this Plotly will be working in the offline mode. And then we are going to import the data set. To import the data set, we know these all are the CSV file. So we are just going to use pd.read_CSV for all the data set. I have given the whole path, if you can see here. Okay, fine. I've given the whole path. So in the first one, we are reading the COVID-19 data, clean data set, then country-wise, and day-wise data set we are reading. Okay, fine. Now, if you'll be looking at this data set, so first of all, let's have a look at the DF, first data frame. So if you'll be looking at DF, okay, so this is the data frame. In this, we have date column, then province or state column. We have many null values here, which we will be replacing just now. Then we have country, then we have latitude, longitude, confirmed, recovered death cases, and active cases. If you'll see, we have the data based on the date. So on 22nd, 23rd, and this data set actually for till October, I think, 11/10/2020. So 11th October till 11th October, we have the data. Now of what this data shows. This data shows starting from 22nd January to 11th October, first we'll be having Afghanistan data. Then in after Afghanistan, whatever the next country will be having again from 22nd October to 11th October. Then third country from 22nd January to 11th October, and so on. So for the different countries, we are going to have the day-wise data. Okay, fine. Now, in this, we want to replace this province or state null values by empty string. So I'll be writing here, this is equal to dot fill NA, and this one. We are replacing it with the empty string. Okay. Now let's print df dot head and execute it. We are going to get the empty strings. Okay. Fine. Similarly, we have the country day-wise data. So let's see the country day-wise data. Country day-wise data we are having. In this, we have the different dates. And in the Afghanistan, so now it is the day-wise data. On 22nd, which all countries we were affected, and what was the confirmed death, recovered, and active, and new cases, new death, new recovered cases. Okay. Next, we have country-wise data. So to get the country-wise data again, if you will be running this, so we have the different country-wise confirmed death, recovered, active, and new cases. Okay. Finally, we have the day-wise data. So only day-wise data, we don't have any country column here. So on 22nd, how many confirmed, how many deaths, how many recovered cases, how many active cases, then on 23rd, and so on, how it was increasing. Okay, fine. So next, what we are going to do is, we are going to get the confirmed, recovered, and death cases. Okay. So to get the confirmed, recovered, and death cases, first of all, we are going to group the data based on the date. So df dot from the first data frame I'll be finding. Okay. From the first data frame, I am going to group the data based on the date. Yes, Subhangi.
What is, can you scroll up little? The first line where you imported data set. Here the connected is equal to true. What is that actually?
We are setting this Plotly to be working into the offline mode. If you will not set this, your Plotly will not work in the offline mode. Okay. Right. Okay. So
Abhishek,
now,
what is this offline and online for Plotly?
Plotly, to work with Plotly, you need to be connected with the internet. Okay. If you will not set it as in the offline mode, so when you will be disconnected, the graph which you have plotted, it will not be shown.
Okay.
Right.
Does
So,
it work like server?
yeah, actually it fits the, like, see, I will tell you where the graph will not be shown. So going forward, you will see that we are doing the plotting of the geographical data. Okay, we'll be using the maps to plot the data. Those maps are taken from the servers. Okay, so those maps you will not be able to see in the offline mode. Fine.
Okay, thank you.
Yeah. So first of all, what we want to group this data based on the date. So I'll be using df.group by on date column. Okay, fine. Okay, what I want the confirmed cases first. Okay, so first of all, confirmed is equal to this, and then dot sum. I'm going to find the total sum of the confirmed cases. So here I'll be writing confirmed. Okay, and finally we are going to get the dot reset underscore index. Right? Execute this. If you will be executing confirmed dot, let's say confirmed dot head, then if you'll be executing it, so see what happened on 22nd January. If you look at this DF on 22nd January, you have this Afghanistan data, right? Correct. Then on 23rd January, 24th January till 11th October, you will be getting the Afghanistan data. But and then on 22nd next, you will be getting the Albania data. Fine. Once the Afghanistan data is exhausted, then you will be getting the Albania data from 22nd to 11 October again. Once that Albania data is exhausted, then you'll be getting the from 22nd to 11th October, you'll be getting the Algeria data. Correct? On this data frame. Fine. So what I have done, that on 22nd, what was the confirmed cases that we have got from here? Okay, so we have grouped the data based on the date. On 22nd, I want all the confirmed cases. So I've grouped it on the date. Okay, then dot sum of the confirmed cases, confirmed column. I've got all the confirmed cases on 22nd. So now, if you see, I am going to get a smaller data frame where date-wise, I'll be getting the total number of confirmed cases. Clear? Fine, everyone?
Yeah.
Abhishek, in the last, we have used that reset index, right?
Yes. Why? Because we are grouping the data, no? So when you group the data together, so from 22nd, the different row value will be taken, right? So index will be random, right? Okay. So what we are doing, we are just getting this default indexing in that case. Okay, 0, 1, 2, 3, 4.
Okay.
Right.
Abhishek, we are using 4 CSV files here, right? This group by is used based
only on the first CSV file, DF.
Only on first.
Yes.
It's okay, got it.
Okay. Similar. So as of now, we are going to do all the plot on this first data frame only. We are not going to touch day-wise or country-wise data at all. Okay. Fine. Okay. Similarly, I want you to calculate the death count on the different dates. So DEATH, deaths. So here this one will be deaths, and group this one will be fine. This will be deaths. That's it. Execute this and let's get the deaths dot hit. So how many deaths were there on 22nd? 17th death reported. keep on increasing. Similarly, we have the recovered. Okay, so here we can say recovered, and here also we have to see recovered. Right, so we have the recovered cases on the different dates. Clear?
To get all the three in one single table, can we give confirmed, death, recovered, like that same?
Confirmed, yes, we can write confirmed, comma, deaths, comma, recovered. Okay, as of now I want to do the plotting for these three differently, so I have kept it different. Okay, fine. Okay, so now we are going to do the plot. So this Go figure, Go is what? Graph object. Okay, so graph object, here we have imported graph objects. This is used to create the figure object. Okay, we have created the figure object like we have created into the matplotlib, and in that we are adding the traces. You remember add underscore access? Same here, we are adding the traces, and we are plotting the different values: confirmed, recover, and deaths. Okay, fine. Clear, everyone?
So x equal to confirmed in brackets we give date. What does it mean? Is it the same thing as date?
1 minute. Yes, this date column we are taking. Okay, so in the confirmed, we are taking the confirmed. So first we have taken the confirmed, this data frame, then we have taken the deaths data frame, and then we have taken the recovered data frame. And in that, in the confirmed, death, and recovered, we have two columns. One is date and one is either confirmed for confirmed, deaths for deaths column, and recovered for recovered. Okay, so we are plotting on the x-axis, we are plotting the date, and along y-axis, we are plotting the confirmed or recovered cases or the death cases. Mode, we are using line plus marker. I'll be showing what this line plus marker is. And then we are using name is equal to confirm. This is just the name of the graph. Line is equal to, we are giving the color and the width for the each plot. At the end, we are using update underscore layout to give the title of the graph. X-axis tick font size is equal to 14 we have given, and y-axis we are setting the number of cases, the title along the y-axis. Okay. Finally, we are plotting this data. So this will give me, Go is not defined. What is that? Graph object. Name Cbon. Okay. Now let's execute this. So we have this one. Now for confirmed, we have red, for recovered, we have green, and for deaths, we have this yellow color. Okay. Now if you will enlarge this, so we have lines and markers. Okay, fine. Clear? Now if you see, this is the plotly graph where you have some visual control also, and you can use this auto scale, or you can use to zoom in or zoom out, and the different controls into this graph. Okay, fine. Clear?
This is specific for that plotly, right?
Yes, this is specific to plotly.
Okay. The other plottings won't be having these kind of. Oh.
Okay. Next, we are going to plot the density map box worldwide COVID-19 cases with time lapse. So we are going to set the time frame. Now, if you, so basically we are going to plot the case density animation on the world map. Okay. So for this, we need to convert this date column into the data frame. This is the date time object, right? We need to convert it into the string data. Why? Because the next plot which we are going to do, there we have one animation frame that takes only the date into the string object. If you will not convert it into the string object, this will be giving you the error. So we are going to plot this. We are using density underscore map box function. Into this, we are passing the data frame. This density underscore map box by default gives you the world map. Okay, and in this world map we are setting the latitude and longitude. When you will hover over any country, it will be giving you the country name, and hover data will show you the confirmed cases, recovered cases, and the death cases into that country on the different date. So animation frame I have set is equal to date, means the different date there will be one animation will be created, and then it will be showing you the confirmed recovered death on the different dates. Okay, color continuous scale I have set it as inferno, so color will be showing inferno. Radius I have taken 7, zoom equal to 0, radius of the circle, zoom equal to 0 and height equal to 7, so height of the graph. Now update layout I have used to set the title, and update layout again I have used to map box style is open street map. This is the type of the map we are using, and map center location there is 0 I have used. Okay, now this, if you will be executing it, so it will be showing you this data on the world map. Okay, fine. Now this is the animation frame at the bottom, which is showing on the different date, and this is the, if you will be bringing this cursor at any country, then it will be showing you the country name and the different data. So date, latitude, longitude, confirmed, recovered, and death cases. Right? Clear? Okay, everyone. Any question? Any question, guys?
This map is now showing for today's 22 of, yeah, okay, 22 of January. Okay. So if we increase the date on any date, then we can see the actual figure.
Yes, you can bring this data. So data is still 10th of October on your 11th of October. So it will be showing till this date on the 11th of October. Okay. The data which I have taken, it is still 11th October only. Okay. Fine.
So Abhishek, this chart is like it has the animation like capabilities, right? If you hit on play.
Yes, it will play. So if you hit on play, it will start showing this. You can see this. So on 25, 28, it will be showing you the different data. Okay. So you can see date is changing, and accordingly, if you see the confirmed and recovered cases will also be changing. Okay. You can see now recovered is increased to 3, confirmed is 3, deaths is 0. So it was 3 till 28 February. On 24, it is now increasing. Confirmed cases are increasing. Okay. Fine.
Okay.
Okay, next we are going to get the cases over time with the area plot. So first of all, I will be using this. So now what we have done, we are first grouping the data, and then we are getting the confirmed recovered deaths and active cases. So if you will be executing this, then what you are going to get, you are going to get a data frame where you will be grouping the data, and the columns will be getting is the confirmed recovered deaths and active cases based on the different date. Okay, and then in that we are getting the maximum date value. Okay, fine. So what exactly now we are going to print is on the last date, means in this last date, for what was the maximum confirmed cases, on the what was the maximum recovered cases, death cases, and active cases. Okay, so that we are plotting here. Okay, using tree map. So in this we have set the value. So here So this is the date of 11th October. On this, what is the total number of recovered cases? What is the total number of active cases? And what is the total number of death cases it is shown? Okay, fine. So we are plotting these three data. Okay, active, death, and recovered. Fine. Clear, everyone?
Yes, Abhishek.
Okay. So now in this graph,
in real life, right? Do we actually go into this kind of coding to get all these graphs, because there are so many other tools available, right? So how does a data scientist appreciate this kind of code
see,
for?
when you will be going to the final level, okay, of the model creation, you will not be using this. You will be using the different other tools like Tableau and Power BI. But at the initial stage, when you get the raw data, and at that time when you want to do some analysis, you will be using this.
Okay.
Right? So you have now in this we have used tree map function, which takes this TM data. What is this TM data? We have melted this data frame temp. Okay, after getting the recovered, death, confirmed, and active cases on the maximum date value, that means on the 11th October, and then we are setting ID underscore vars is equal to date and value underscore vars is equal to active date recovered. Now, if you remember melt function, what it does, melt function value underscore vars, so it will be melting this data frame. Okay, so on the different date, you are going to get the active data, death data, and recovered data. Okay, fine. So if you will be printing TM here, you will be printing TM. So you can see on 11th October, it is the active data, death data, and recovered data. Okay, this is what we are plotting. Okay, so we have passed TM into the tree map. Path is equal to variable. Okay, the variables which we have taken, and this variable column. Okay, and values is equal to the value which we have taken from here. Then height we have given and the width we have given accordingly. Okay, of the graph. Right? Color discrete sequence for active, recover, and that we have used accordingly. Fine. Okay.
Please explain line number 2 in same.
Line
10 equal to yes, where reset index drop, we use drop here. What is that actually? I don't understand.
Okay, so if you'll be printing the temp, what is this temp? It is the maximum date. Okay, yes. What we are saying, temp is what? If you will comment this, then what is this temp? On the different date, what is the confirmed, recovered, and death case?
Active, yes. Yes.
Now, what we are doing in this, we are first we are accessing based on the date value or date column. We are getting the maximum date. Okay, and on that date, I want the confirmed cases, recovered cases, and death cases and active cases.
Total.
Okay, fine. So maximum date is what? 11th of October. That is what the data we have. So we are getting on the maximum data. That means 11th October. What was the confirmed, recovered, death, and active cases? That is what we are getting. And then we are melting this data using the melt function.
What if we use drop is equal to false over there in reset index?
Then see, no, reset index is the first one. If you'll be setting here drop is equal to false, here it will not be showing any difference. Okay? So index was 263. Clear? You have value here. So that also will be coming. We don't want this index, so I'll show you the test.
Okay. Thank you.
Abhishek, can you please explain the 10th line? Just scroll up a bit. This 10th one.
10th one, this one?
Yeah.
Okay. So figure data, text info. What info you want to show? Labels you want to show, text you want to show, and value you want to show. So when you are hovering over this data, you are able to see this label, and the inside the label you are able to see the text and the value also, right? So value is equal to this one and labels is equal to recovered. Okay, Fine. So 3 information you are able to see: label, text, and value with this one. Clear?
Okay. Okay.
Okay. So now next we are going to get the area plot, okay, of this recovered depth and active cases. Okay. So to get the area plot, we have px.area function. We have again grouped this data based on the date and recovered death and active cases. We have found the same thing which we have done here. Okay. Now this time only for recovered death and active. Okay. Then we have melted the data based on the date column, and we are getting recovered death and active cases, total number of recovered death and active cases. Variable name I have set as case and value name I have set as count. Okay. So now if I'll be printing this temp, after executing this. So this temp shows me the recovered cases on the different dates, then the active cases on the different dates, and then the death cases on the different dates. Okay, date wise basically. Okay, so we have plotted this date wise data of the recovered death and active cases. Now if you'll be seeing here update underscore layout, I have set here x-axis range slider visible equal to true. This is the range slider. Okay, if you set it as false, then this range slider will not be shown. Okay, now x, we are plotting this temp data. Along x-axis we are keeping date, along y-axis we are keeping count, and color is equal to case, and then height is equal to 600, basically height of the graph. Title we have given, color discrete sequence we are using, that of the active recovered death, which we have set in the beginning. Okay, this color we are taking from there. Okay, fine. So this is
one question. Actually, what is the difference between this and count plot? This also we are doing against count, right, in y-axis?
count plot. Where is the count plot? We have done it here.
No, in general, basically, like in the last example with Titanic, we did like count plot, right? So here, like, we are giving x equal to date and y equal to count. But in count plot directly, y is always count. Is my understanding correct, Abhishek?
Count plot is the univariate analysis. Okay, you can give only one single variable. Okay.
Okay.
Here you are plotting two variables: date along the x-axis and count along y-axis.
Okay. Yeah, thanks, Abhishek.
Okay, fine. So see, these all are the advanced plot which you will be not getting into the Matplotlib and Seaborn. So we have specifically into the Plotly only. Okay. Next, we are going to get the Choropleth map. So in the Choropleth map, we are going to get, with respect to the different country-wise data, we are going to plot this data. Okay. So first of all, we are going to take country day-wise data. This is the country day-wise data. On 22nd, what was the count in the Afghanistan, then in Albania, in Algeria. On 22nd, first it will show the data of all the countries, then on 23rd January, then 24th January, and so on. Okay, so we are going to do the Choropleth map plotting for this data. Now what we are passing country day-wise, and locations is equal to country. This country column we are passing for the locations. Location mode, I am passing country name, which will be taking the ISO standard country name. Okay. Color, I am passing country day-wise, this confirmed cases. For the confirmed cases, I am just plotting. Hover name, when I will be hovering over the country, it will be showing you the country name. Animation frame, I am setting as the date, and that is into the, again, date time string format. And then title, I am taking this title, I am setting the title. And then color axis show scale, I am setting it as 2, so it will show me the color axis also. Okay, so let's execute this. This is the Choropleth map, and this is the color axis we have. And on the different dates, we are having this. So this is also setting the animation frame. On different dates, it will be showing you the cases. So as of now, we are on 22nd of January, where it is showing the 0 number of cases in almost all over the world. Only the China was having more cases, 548 cases. So this is showing here into the yellow color. As this will be increasing, this color will be start increasing towards yellowish. Okay, so towards here it will be become red. Right? Clear? Okay, everyone.
Can you scroll up, please, Abhishek, once?
Yes.
Yeah. Okay, Abhishek.
Okay. Now, next we are going to get the death and recoveries per 100 cases. For that, I will be taking the day-wise data. Okay. Deaths and recoveries per 100 cases we are going to get. For that, I'll be taking the day-wise data. What all day-wise data we have? So we have this day-wise data. Okay. And then we are going to get the plot. Basically, now we are going to get the, it is similar to the bar plot. Okay. But we are using the plotly to.
Abhishek, just before we go into this one, so to summarize, like Choropleth would be a field map, right? Field map with continuous measure by something like that.
Yes.
So like it's location mode, that location mode will be like I mean, what does it exactly?
No, this is the standard set of value. You have to give country names only. This takes the IOS standard name. So here it is showing India, right? It will not be showing, it will not be. Right? Clear? So it is the standard. If you check this value, so here you will see in the location mode, location mode, STR one of the ISO 3 USA states or country names you have to provide. Okay.
Okay, so the same can be done if this is like a worldwide data, right? So suppose we have a data specific to a specific country. So in that case, can we drill down the data to like the state level, like instead of locations, country?
No. Only 3 values you have, as I said here. You can see it here. Location mode has only 3 values: ISO 3, USA state, or country names. Either you can have world map or you can have USA map.
USA map. Okay. Okay.
Fine. Now we are doing the bar plot. So in the bar plot, we are giving the day-wise data. Along x-axis, we are taking date. Along y-axis, we are taking the confirmed cases from this data frame. And for this, we are going to use ELF. And for death, we are going to have DTH. Okay. Now, so this is, we are doing the bar plot, and then we are making the subplot. So now if you'll see, this subplot is similar to the subplots function into the matplotlib, where you are going to set the rows and column attribute. Shared x-axis you are setting false because both will be 2 different plots. Horizontal spacing you want between them at 0.1, and subplot title you want to set the title as confirmed cases and death cases. Now we are adding the traces for the confirmed cases and death cases with row equal to 1 and column equal to 1, row equal to 1 and column equal to 2. So here you will not be using 0 based indexing, you will be using 1 based indexing. So it starts from 1. Okay. So now if you will be executing it, you will see this is the 2 graph we have. Okay. This is 1, 1 graph. This is 1, 2 graph, means 1 row and 1 column, second column. Okay. This row is indexed at 1. This column is indexed at 1. This column is indexed at 2. Clear? Fine. So if I want to plot into this, row will be what? 1, column will be 1. If I want to plot into this, row will be 1, column will be 2. That is what we have done here. Okay. Fine, everyone.
Abhishek, this data, line number 7 and 8, add trace fig C, in brackets you have mentioned data. So data 0, this is going to be pulling.
this is figure underscore C, right? We are plotting
Yeah.
px. In that we are first data. So if you'll be plotting figure underscore, you'll check figure underscore C has two values. Not this one. Okay, it is giving me the plot. What I can do. Okay, so let's see it here. Px dot bar. Basically, it returns a set of values with height. Now, let's see it here. Yes. So this gives you two values. Okay. So if you'll see here, it is the data key and the layout key. Two keys you have, right? In the data key, it is returning a list of values, right? Clear? Fine. And in this list, you have the first element, which is a dictionary. So we are passing this argument to this figure underscore C of data of 0. Understood? So the only the first value we will be always interested in, because we want to plot the data. We don't want to get the layout, right? So we are accessing the data key, and in that data key, the value is list. So the first value is we are accessing from here, which is a dictionary, okay, which is giving me the data, fine, which we want to plot. Understood?
Okay.
Okay, so what this figure underscore C is, if you'll see px dot bar, it returns this figure object, which has two values. One is the data key, one is the layout key. In this, we are accessing the data key out of the figure underscore C, and this data key is having a list of values. Out of that, we are accessing this first value. Okay, fine. Okay, so next, what we are going to do is confirmed and death cases with static color map. So with this static color map, we are going to use again Choropleth map, and the color code we have used the different color codes we have used here. Okay, now we are getting for the confirmed cases separately. We are plotting the Choropleth map. Then we are doing it for the death cases, and then we are adding the traces with creating the subplots. Okay, so now if you'll be executing it, so it is showing for the confirmed and death cases on the different region. Fine. Clear? So these all are the different plots I have done on this. So there are a number of other analysis also, like death per 100 cases or the new cases or top 15 countries analysis. So for the top 15 countries analysis, I'll be just showing you, I'll be explaining you one, and then probably it will be done for the rest of the all. So skip this one. This is a bit heavy graph, so it will take some time to execute. Yes. So this is the top 15 countries analysis. Now what I have done, I've got the top 15 countries data of the confirmed cases, for the death cases, for the active cases, recovered cases, death per 100 cases, recovered per 100 cases, new cases, death per 100 recovered cases, and all. Okay. Finally, after getting all these different cases, then we are adding it to the different traces. And how many plots we have? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Total 12 plots we have. So 6 cross 2 we have created. 6 rows and 2 columns. So this is what the plots we have. Number of confirmed cases, number of deaths reported. Then we have number of active cases, number of recovered cases, death per 100 cases, recovered per 100 cases, and so on. Okay. And this is for only top 15 countries. Okay. Fine. Clear, everyone? Now, in this, we are using only the bar plot. So we are passing the confirmed cases, and then along x-axis, we are passing the confirmed
Abhishek,
column.
why you use top is equal to?
Top is equal to 15. I told you, I want only for top 15 countries.
But where we are using 15 below code.
Dot tail top, dot tail 15 countries.
Okay, okay.
Is it sorted in ascending order so that at the bottom top 15 countries will come? That is why we are taking time. Is my understanding correct, Abhishek?
Yes, yes, Vishal.
Okay.
Sort values and then top. Okay.
Yes. Tail top. So bottom countries will be at the highest. So at the end, you'll be having highest values, right? Okay, so tail top we are doing. Okay, fine. So this is it, like the different plots I have done. See, this plotly you are not going to. I think it is not being used into this. What do you say? Much of the plots. Okay, it is mainly used for the geographical plot and very advanced plot. But still, I think that will be covered into your stats classes. This plotly after stats or after ML, this will be covered. If it is not covered also, you have seen a lot of useful function. You can use this plotly. The only drawback into the plotly is the graphs are very much heavy. Okay, your system will become slow. So there is one more plot which I'm not doing, because if I'll do that plot, I'll not be able to scroll it at all. Okay, so that I'm leaving up to you. You can use in your system, and you can plot that. So I'll be sharing you this COVID EDA file also. So this plot I will be sharing with you. This plot, if you see this plot, I have commented at the end somewhere. These plots are very heavy plot, bar plot and line plot. When I did first time, my system got stuck. So I'm not doing it. You can do it. And these all are the simple ones. So the way you have done the bar plot, you are going to pass the data x-axis, y-axis, color, height, title, and the color discrete sequence, whatever the color you want. Okay, fine. So this is it. Rest all we have done that. Okay, so you can find it. You can download this file from the LMS, and you can practice it. Okay, your data science classes are over. You have these stats classes. I think it is starting from tomorrow. Take your time, keep practicing. By next week, probably we will schedule the test. So by then, I think you'll be able to complete all these things. Okay.
Test includes all that we have covered so far in Python, including these bars, charts.
Yes, yes, yes.
Okay, from the beginning class. Okay.
Test will be simple, don't worry. It will be simple, you'll be able to clear. If you would have given, you would have cleared it.
Okay, okay. I mean, what is the class time tomorrow afternoon?
Tomorrow, yes, afternoon, 12:30.
Starts class. Okay, 12:30. Okay.
Abhishek, the test would include all these plots as well?
No. It will not include all those things.
And it will be till pandas?
It will be till NumPy, pandas, and all. NumPy, yes, NumPy and pandas. That's it.
Is it MCQ type or else we need to write code or something?
MCQ type only. Most of the this one will be MCQ type. I'll tell you around 9 or 10 questions are the MCQ type, and rest 4 or 5 questions will be the code you have to write, and that code is also going to be 1 line or 2 line code you have to write. Okay.
Okay.
So data set is uploaded. Done. So I've uploaded all the files now. Okay, go ahead and practice it. And I have shared you guys the link of the Titanic data set. Hope you guys have copied it and pasted it, because that is the link. Let me upload that link also. 1 minute. Anything else, guys?